In this video, we are going to talk about the slope of a line. So what is slope? In normal conversations, when we say slope, we usually associate it with the steepness of a climb. Say if we are asked, how steep are the stairs? We usually give an estimate in terms of angle of inclination. Angle of inclination. So that if we say the climb is, say, 60 degrees, then we expect that it's a hard climb as compared to a, say, 10-degree angle of inclination. So when we say slope of a line, we mean the angle of inclination of that line. Meaning, if this is the line, by angle of inclination, we mean the angle with respect to the horizontal, like that. So, if we are to consider a line drawn on the xy plane, say this is our xy plane, this is x, this is y, say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Say, let's consider a line where x is equal to y. That is, whatever is x, its y value is the same as x. So, when, say, x is 0, y is also 0. When x is 1, y is also 1. We mean this line. This line. So what is its angle of inclination? Its angle of inclination would be this, say, theta. Now the most common or the most familiar technique in finding the angle of inclination is to make use of trigonometric functions. Say, so, ka, and toa, depending on which sides of the right triangle are given. So we can only use this if we have a right triangle. So we are going to construct a right triangle somewhere in our line. So how do we do that? It's quite easy. We will just choose 2 points, say these points, 2, 2, and say this point, 5, 5. By angle of inclination, we mean this, theta. Of course, this theta is the same as this theta because the red segment is parallel to the x-axis. To construct the right triangle, we're just going to close it here. So let's close it. So we now have a right triangle. Right triangle. So, of course, we have 3 sides. And the sides that are easy to solve for the lengths of the lengths of the sides are this and this leg and this leg. Why is that? Because for the vertical leg, since this is 5 and this is 2, we will just subtract 5 by 2, which is equal to 3. It's the same with the horizontal leg. Since this is 5 and this is also 5, this is also 2, then this side can be computed by subtracting 5 minus 2, which is equal to 3. So what do we have here? We have a right triangle whose legs have equal measure, which are equal to 3. So to solve for the angle of inclination, we'll make use of the tangent function. That is tangent theta is equal to the side opposite over side adjacent. Side opposite is 3. The same with the length of the side adjacent, also 3. That's equal to 1. So tangent theta is equal to 1. And so theta is what? It's equal to the inverse tangent of 1. Therefore, theta is pi over 4, which is equal to 45 degrees. So we were able to solve for the angle of inclination. But it's actually difficult to solve for the angle. As you can see, we need to make use of the tangent function as well as its inverse. Huh? So, what if it's not 1? What if it's something else, like 7 over 5 or 1 over 11? We would have a hard time finding the angle, the exact value of the angle. So the slope of the line is defined as the tangent of the angle of inclination. Slope of the line is simply equal to tangent of theta, where slope is denoted by m. So going back to our triangle, since the opposite side is the vertical leg, this, whose length was computed by subtracting the y coordinate of the second point minus the y coordinate of the first point, m can also be described as the change in y over the vertical leg, which is just the change in x. The change in x. Now, the notation for the change in y is this. We read that as delta y over delta x. So, the slope m is also equal to delta y over delta x. Note that the opposite side is a vertical segment, which is sometimes referred to as the rise, while the horizontal segment is sometimes referred to as the run. And from there, m, which is the slope of the line, is also described as the ratio of rise over run. Rise over run. So this is now the slope of a line.